In this video, we're going to have a look at running a stress simulation on Fusion 360. So, as a teacher, I'd like to think I've got quite a lot of experience working with stress. So, hopefully, this video is going to teach you a thing or two about how to set up a study as well as analysing the results that it gives us. So, just a brief explanation of what a stress simulation is. It's sometimes referred to as finite element analysis as well. It is essentially having a look at a component working under mechanical stress or a force and seeing how it's going to behave and how well it's going to last working under those forces. So let's jump into Fusion and have a go at setting one up. This is the CAD model that I'm going to be using to run my study. It is a anti-vandal button made by a company called Bulgin. Now, this seems like quite a good component to use because with it being anti-vandal, it has to be able to cope under different stresses. So because the design of this is already done, we're going to switch our workspace from design over to simulation. When you click on that, it's going to give you a list of different simulations to run, and we're just going to stick with static stress and click create study. Now, what you'll notice is we've still got our browser on the left and we've still got our tools at the top. And we're going to try and stick with that left to right along the top, just so we can make sure we're setting everything up in sensible order. So we're going to look at the first one, which is setting up a study. We've literally just done that, so we can just skip this one. Next one is simplify. Again, we're not going to use this one, but what this will do is it'll take a really complex design, complex shape, and it'll eliminate some of the finer details. And this just allows you to run a much quicker study and get a general idea of whether it's worth running another study or whether you need to redesign something slightly different. Now, this one, as it says, is all about how you change the properties of your materials. So, seems like a pretty sensible name to me. And within this, what you can do is you can select the materials that are going to be part of your study. You can view the material properties. You can actually start to change those. Maybe you've got a material that's got a slightly different strength to what's already on Fusion. And you can also change the color of those so that you can actually see the different materials on your model. So we're just going to go with the top one and we are going to look at what study materials we are using. So within this, you get the option of changing it component by component, which is nice and handy rather than just changing the entire design. Now, the default is going to be the same as the model, so it's the same as the physical materials from the design workspace. You can change that using the pencil tool, and you can select from a load of different options, including air. Not really sure why that one's on there and how you would run a static stress study with air, but it's there anyway. But we're just going to stick with the same as the model for now. We're just going to stick with this steel. Click OK. And the next one along is constraints. Now, this is a bit similar to sketch constraints. All we're doing is locking a component in place based on some different rules. We've got bolt connector, using the name again, it's going to be attached using some sort of bolt or screw. Got rigid body, which you select an anchor point at a point on a body. And this one that we're going to go with a structural constraint. So I'm just going to move my floating head out the way. So within this one, there are some different types depending on how the actual components are going to move or whether it's actually going to be fixed in place. So for this, we're just going to stay with fixed and we're just going to select the components that are being locked in place and where they're going to be locked in place. So I'm going to lock into place the underside of this, as well as the buttons along the top as well. Now with this, you can select either an edge or a face to lock it in place. And once you're done adding those, simply click OK. Now The next one along is loads, and this essentially is what forces are being applied to that component. So we're going to stick with structural loads at the top, and we're going to select where the force is actually being applied. And we can also change this if we wanted to as well. So you can change it within different forces, or maybe it's not just a static force and it is some sort of motion. But again, we're just going to stick with force for this one. Now, with this product, when they do their actual physical test, they drop a weight onto this. So that means it can hit anywhere along this top face. So I'm just going to add a few different loads along this top face. I'm going to type in a value. I've gone with 10,000. Now that just gives me a nice wide range of data to give a bit more of an analysis when we look at the results of this simulation. As well as changing the amount, you can also change the angle that it's hitting at, and you can also flip the direction on this. Once you've added all the ones that you need, simply click OK, and we can go on to the next one along. So this one, contacts. This is essentially for if there are multiple parts within your design. Running this allows Fusion to understand where different parts are going to hit each other or collide, or where there are going to be gaps in this. So you can run it as an automatic contact and it will just simply figure out itself, or you can go with manual if you want a bit more control on this. So I'm going to add one as manual before running the rest as automatic. So I'm going to select no. And I'm going to select this button just here, and I'm going to attach it to this side just here. And I'm going to add outside of this face to this inner part of this face here. Now, just here where it says contact type, as this is a button, this is going to be a sliding contact, just to allow that button to be actually pressed, and just click OK. So now that I've set up my manual contact, I'm going to be a bit lazy or efficient if you want to look at it positively. And I'm going to go on automatic contacts this time instead. And it's going to give us a contact detection tolerance. This is basically how close do the parts have to be together in order for us to register it as touching. I'm just going to go with about 1mm and just click generate. And it just automatically generate those contacts. Can change them through the manage contacts and just double check that they're as you'd like them to be. Next one along is display, which we're not going to use in this video, but all it does is just jumps between different ways of showing your study. You can also go to manage and you can control some of the different settings that we've already set up. A really good one when you get a bit more understanding of this is this local mesh control. Now, the greater the complexity of that mesh and the more small triangle it has within that, the more accurate those results will be. But the downside of that is the more mesh there is, the longer it's going to take to set up and run that study. So what I tend to do when running these is leave it as it is. And when I run it a second time, I'll add a bit more mesh to the areas where there is a bit more detail. So next thing is we're going to move on to solve, the bit we've all been waiting for. For them, and that is pre-check. As you can see, red means for whatever reason it can't run the study, and it will usually tell you why. Orange, bit of a warning, but you can still run it. You just have to wait with fingers crossed for your results. And green doesn't have any predicted issues. Now that doesn't mean it's going to be perfect, but it's not predicting why that's not going to be. So we're just going to go straight to solve and hope for the best. Click on solve study and just wait for the results.